Today's problem is maximum path sum, difficulty is medium. Medium. This problem I've seen on LeetCode also. Over there they have it ranked as hard. I don't know. The accuracy here is kind of low. The average time is kind of high. So it's hard or on the harder side of medium. Anyway, given the root of a binary tree, your task is to find the maximum path sum. The path may start and end at any root in the tree, meaning it doesn't necessarily have to go through the root, as in this second example here. Let's see. Okay, yeah, so they give trees, they give examples of maximum path. Note that it has to be a path. For example, we couldn't add this one node here to get a bigger sum because it's not a path. I mean, you would have to go, to the one and back out, and so on. All right. Number of nodes between 1 and 1,000. Data in the node will be between negative 10,000 and 10,000. Expected complexities. O of n. Auxiliary space O of n. I'm trying to think. Well, I mean, it's recursive, so you're going to need some space for the recursion stack. Company tags, topic tags. Not really any hints there. All right. Let me scoot this over a little. I want to be able to see. Well, actually, you know what I could do, so we could see everything as well as to be able to see the problem. Yeah, we could do it like, can we do it like that? Didn't really help that much, but let me see what happens if I move this over a little. Can we see everything? Yeah, I think so. How about here? Yes. Okay, all good. Well, let's look at this first problem. It's a little tricky to track it because of the recursion, but we're going to initialize a variable here, max sum, and eventually we'll return that variable, but we'll initialize it to a very small value. This just kicks off the recursion, calculate max sum with the root, and then we return it. All right, so calculate max sum. So what comes in here initially is the root. That is a 10. Is the node null? It's not null. So we'll calculate the left max sum, which is the max of either 0 or the max sum of the left node. Okay, so that's a recursive call. So we'll make another call to calculate max sum with this too. So we'll come in here. And again, we're going to have to calculate the left max sum using the left node. So we'll call it again with the 20. Coming in here with the 20 is the node null, no left max sum. Well, left max sum and right max sum of the 20, those are both going to be 0. Okay, let me get a pen here. Oh, I don't want that in white though. So let's do it like, let's do it like this. All right, so we'll say max. All right, left max sum, math max right now is initialized to a very large negative number. So we're calling this with the 20. Left max sum is 0, right max sum is 0, max sum equals math max of max sum or node data, which is 20 plus 0 plus 0. So max sum is now 20. Return node data plus 0. All right. So what comes back up here is 20. All right, so that takes care of the left max sum of 2. Right max sum of 2 is, well, if we calculate this, it's going to be, and this is 20, this is 1. Let's see, so the max sum, that 1 doesn't affect the max sum. For the 2, we're going to return the node data plus the max of 20 or 1, and that would be 20. So what comes back up here is 22. 22. All right. Again, it doesn't come back up as 23 because we can't include both 20 and 1 on a path. It's got to be a path. We've got to be able to just go from start to finish without any backtracking. All right. So now we've got left max sum of the root. Now we're going to go right max sum of the root, which is 10. All right. Right max sum of the root. Okay, so now we need a recursive call to this 10 right here. So that comes in left max sum. Left max sum of that is 0. That's actually important. Right max sum of that, we have to compute the max sum of the negative 25. All right, so the negative 25 comes in. What is the left max sum of that? Well, it's a 3. And what comes back up is a 3. Max sum of this is 4, and so we'll send back up a 4. Max sum equals max of whatever it is now. Oh, you know what? I should have updated max. Max is now 22 because we have a path here. 22. 20 and 2. All right, max sum, there's a node data negative 25 plus something something. Well, that isn't going to be the max sum. Return node data is the max of negative 25 plus 4. All right, so what comes back up here is negative 21. It's not so good. All right, so now we have the left max sum and the right max sum of this 10. Max sum, we're not going to get a new max sum out of that. So we'll return the node data. And the node data is it's node data, which is 10, plus the max of 0 or negative 21. Well, so let's use the 0. So the node data, so what's going to come back up here is 10. Okay? So now we have the left max sum and the right max sum of the root. So we'll say max sum equals max of the current max sum or node data, which is 10, plus the left max sum, which is 22, so that makes 32, plus the right max sum, which is 10, so that makes 42. Return the node data. That's not really important, but I mean, what it would return is 10 plus the max, it would return 32. But what we care about really is this max sum. So that would give us an answer of 42. Okay. Let's get rid of all that. That is the correct answer, isn't it? Oh yeah, we can see it right there. It's 42. All right. So let's try and run it. All right, good. So a tree, a tree problem like this, max sum, I mean, you're probably going to want to try to think of some sort of recursive solution. Trees are recursive data structures, and solutions to problems involving trees are often recursive algorithms. The tricky part here is this calculation of the max sum, which is different from what is actually returned by the recursive call. That's the tricky part of it, is making sure that the answer is a path rather than a subtree. All right, that's it. Feel free to like the video. I hope you do that and subscribe to the channel, and we'll see you next time.